pleasantries. Good day, everyone. So, today we will be talking about the overview of grid computing. So, technology plays very important roles in every aspect of our lives, so does grid computing. This technology has been applied to computationally intensive scientific, mathematical, and academic problems through volunteer computing, and it is used in commercial enterprises for such diverse applications as drug discovery, economic forecasting, seismic analysis, and back-office data processing in support for e-commerce and web services. So now let's talk about what grid computing is and its uses.
Grid computing is the use of widely distributed computer resources to reach a common goal. A computing grid can be thought of as a distributed system with non-interactive workloads that involve many files. Grid computing is distinguished from conventional high-performance computing systems such as cluster computing in that grid computers have each node set to perform a different task application. Grid computers also tend to be more heterogeneous and geographically dispersed, thus not physically coupled, than cluster computers. Grids are a form of distributed computing composed of many network, loosely coupled computers acting together to perform large tasks. For certain applications, distributed or grid computing can be seen as a special type of parallel computing that relies on complete computers with onboard CPUs, storage, power supplies, network interfaces, etc. connected to a computer network, private or public, by a conventional network interface such as Ethernet.
There are other uses of grid computing. Grid computing offers a way to solve grand challenges problems such as protein folding, financial modeling, earthquake simulation, and climate or weather modeling, and was integral in enabling the Large Hadron Collider at CERN. Grids offer a way of using information technology resources optimally inside an organization. They also provide a means of offering information technology as utility for commercial and non-commercial clients, with those clients paying only for what they use, as with electricity or water. Alongside with this, grid computer is used in the movie industry due to its ability to do tasks more efficiently and save time. Computers help add effects, but they also allow the film to made quicker than usual using grid computing. Also, grid computing finds another fields of work in gaming industries. With this increase in users more interested in online gaming, the traffic has increases, and this is where grid computing helps processing faster and better. The amount of the data that is handled by the government is huge, and handling so much data and then processing it becomes much easier with the use of grid computing.
So to further understand what grid computing is, let's discuss how grid computing started. So the term grid computing originated in the early 1990s as a metaphor for making computer power as easy to access as an electric power grid. The power grid metaphor for accessible computing quickly became canonical when Ian Foster and Carl Kesselman published their seminal work entitled The Grid: Blueprint for New Computing Infrastructure in 1999. This was preceded by the decades by the metaphor of utility computing in 1961, computing as a public utility analogous to phone system. The ideas of the grid, including those from distributed computing, object-oriented programming, and web services, were brought together by Ian Foster and Steve Tuchman of the University of Chicago and Carl Kesselman of the University of Southern California's Information Sciences Institute. So the trio who led the effort to create the Globus Toolkit is widely regarded as the fathers of the grid. The toolkit incorporates not just computation management but also storage management, security provisioning, data movement monitoring, and a toolkit for developing additional services based on the same infrastructure, including agreement negotiation, notification mechanisms, trigger services, and information aggregation. While the Globus Toolkit remains the de facto standard for building grid solution, a number of other tools have been built that answer some subset of services needed to create an enterprise or global grid.
Now that I have discussed a general overview of grid computing, let's now talk about the different types of grid computing. Grid computing is generally classified as follows: computational, scavenging, and data grid. Firstly, let's talk about computational grid. Computational grid consists of high performance computers. It allows researchers to use the combined computing power of the computers. Researchers use computational grid computing to perform research intensive tasks such as mathematical simulations. Next one, scavenging grid. While similar to computational grids, CPU scavenging grids have many regular computers. The term scavenging describes the process of searching for available computing resources in a network of regular computers. While other network users access the computers for non-grid related tasks, the grid software uses these nodes when they are free. And lastly, data grid. Data grid is a grid computing network that connects to multiple computers to provide large data storage capacity. You can access the stored data as if on your local machine without having to worry about the physical location of your data on the grid. Since we already know the types of grid computing, let's now answer the question why grid computing is important. So, organizations use grid computing for several reasons. First one, efficiency. With grid computing, you can break down an enormous, complex task into multiple subtasks. Multiple computers can work on the subtasks concurrently, making grid computing an efficient computational solution. Second one is cost. Grid computing works with existing hardware, which means you can reuse existing computers. You can save costs while accessing your excess computational resources. You can also effectively access resources from the cloud. Third one is flexibility. Grid computing is not constrained to a specific building or location. You can set up a grid computing network that spans several regions. This allows researchers in different countries.
Let's now discuss the advantages of using grid computing. In the shorter amount of time, bigger, more complicated problems can be solved. Make better use of existing hardware. It is easier to collaborate with other organizations. This model scales very well. This modular environment really scales well. No need to buy a six-figure SMP. Server for application that can be split and farmer out to the smaller commodity type of server. Grid environments are much more modular and computing don't have single points. Policies can be managed by grid. Software is really the brains behind grid computing. Much more efficient use of the needle resources. The job can be formed out to the middle servers or even needles desktop. A grid environment is exactly well the settled to run job. It can be split into a smaller trunks and run on the several nodes supplementary. With this big and difficult problem can be solved in the short time, can be easily collaborated with other organizations. It works as a supercomputer so that we do not have to buy much an expensive computer. By these resources can be used more effectively. There is no risk to fail even if when the system fails, it has no effect on other computer. If we want to upgrade it, when we can upgrade without downtime. In grid computing, the tasks are divided into small tasks. When these tasks are divided into many computers so that the tasks are complete easily.
She already discussed the common advantages of using grid computing. But let's discuss the possible risks and disadvantages of using grid computing. First, political challenges associated with sharing resources. Many groups are reluctant with sharing resources even if benefits involves everyone. Second, grid computing technology, the software and standards are still evolving processes. Third, the learning curve to get started. Fourth, non-interactive job submission. Fifth, we'll be forced to run a large SMP for memory-hungry applications that can take advantage of MPI. 6. In this computing, the licensing across many servers may make it prohibitive for some apps. 7th, the applications would need tweaking to take full advantage of new models of computing. 8. You may need to have an interconnection between compute resources. Despite the described disadvantages of grid computing, this technology has many benefits, and it seems likely that it will be used more and more in different computational grid projects, especially for biomedical, industrial, and financial research, but also in chemistry and medicine. One of the most famous exponents of grid computing is the European Organization for Nuclear Research, or CERN. Now, let's discuss the market value and companies involved in grid computing. There are leading vendors in grid computing that includes Data Synapse, HP, IBM, Oracle, and Platform Computing. Data Synapse offers its grid server software for commercial applications. Grid Server creates a self-managed grid computing infrastructure. HP has endorsed grid technology in a big way. Their current support includes grid-enabled systems running HPUX, Linux, and True64 Unix using the Globus toolkit for HP platforms. IBM offers grid products based on Data Synapse middleware for the banking and financial industries, including risk management and customer analytics products. The company has landed hundreds of millions of dollars in contracts to build grid infrastructures for universities and governments. IBM has relationships with leading grid tool and application providers. Oracle provides substantial grid computing technology. The Oracle database 10-gram leverages grid-enabling hardware innovations and automatically provisions clustered storage and servers to different databases running in a grid. There are also industries that benefited a lot in using grid computing. This includes life sciences. There are various life science disciplines such as computational biology, bioinformatics, genomics, neuroscience, and others have embraced grid technology rapidly. Medical practitioners can access, collect, and mine relevant data effectively. The grid also enables medical staff to perform large-scale simulations and analyses and connect remote instruments to existing medical infrastructure. Second one, engineering-oriented and applications. NASA Information Power Grid, or NASA IPG, has deployed large-scale engineering-oriented grid applications in the US. Third one, data-oriented applications. Distributed Aircraft Maintenance Environment, or DAME, is a fit use case of a data-oriented application. DAME is a grid-based distributed diagnostic system for aircraft engines developed in the UK. It uses grid technology to manage large volumes of in-flight data collected by operational aircraft.
To continue, the fourth industry that benefited a lot from grid computing is scientific research collaboration. Organizations involved in research collaboration require substantial storage space as they regularly generate petabytes of data. They also need advanced computational resources to perform data-intensive processing. In this case, grid computing provides a resource sharing mechanism by offering a single virtual organization that shares computing capabilities. And lastly, commercial applications. Grid computing supports various commercial applications such as the online gaming and the entertainment industry, where computation-intensive resources such as computers and storage networks are essential. Other technologies that uses grid computing are Set-at-Home project, Berkeley Open Infrastructure for Network Computing, LHC Computing Grid, Folding at Home, Einstein at Home, Great Internet Machine Prime Search, World Community Grid, and NASA Information Power Grid. There are also various real-world examples of grid deployments. This includes Hartford Life. Hartford Life is using a grid network to handle intensive financial analytics, measuring market conditions and market behavior. Antelos, a biotechnology firm in California, uses a grid structure to speed the process of drug discovery. It can run simulations in a matter of hours or days with its network. Wachovia's fixed income derivatives trading unit runs trading simulations on a grid network to reduce risk and enable the firm to make larger trades. Cadence Design Systems integrates grids into every aspect of its production environment. In particular, it incorporates grid technology into its software development and chip design processes. Johnson & Johnson uses grid technology to run powerful applications that model clinical trials of pharmaceuticals. Pharmaceutical giant Novartis has linked nearly 3,000 of its researchers' personal computers in a grid that delivers more than 5 teraflops of computing power. This enables the researchers to examine bigger datasets with greater precision and to target new problems. Bank One is using grid middleware technology to distribute risk analytics processing. It aims to cut hardware costs while increasing performance of analytics for its interest rate derivatives trading business.